Hi guys, we today continue solving our task, and the next task would be the following. We are finding champions. So there are n teams numbered from 0 to n minus 1. Each team is also a node in a duck. Duck is directed acyclic graph. You are given the integer n and 0 indexed integer array edges of length m representing the duck. Okay, and indicates that there is a direct edge from U to team V1 in a graph. A direct edge from A to B in the graph means that team A is stronger than team B, and team B is weaker than team A. Team A will be the champion of the tournament if there is no team B that is stronger than team A, and return the team that will be the champion of the tournament if there is a unique champion. Otherwise, return -1. All right. A cycle is a series of nodes such that node A1 is the same node as an an plus 1. Okay. A duck is direct graph that doesn't have any cycle. All right, so we have here 0, 1, and 2. So we have such such combinations of connection between nodes. And we have 3 nodes actually. So team 1 is weaker than team 0. Team 2 is weaker than team 1. So the champion is team 0. All right, so let's check. So first, let's check our inputs. So first input is n. So do we have 0 nodes? So I expect to have at least 2 nodes, and the maximum, let's say 1000 nodes. And m length, it would be from 1 to also 1000. All right, so yeah, so we can have 1 node, and here we have 0. All right. Okay, great. Let's check then how can we actually solve it. So we can create like a map of these connections. Yeah. So we can check like from 0, we can go to 1, and from 1 to 2. But let's imagine that we have, for example, 4 nodes, and we have 3 that is greater than 0, and 4 that is greater than 3. So in this case, when we construct such map, here we can have also like 2, right? So such connections like this. So we can take 0. So we take 0. 0 would be our possible winner, and then we go to 1, 2, 2, we don't have any connections. Yeah, 2, we don't have any connections. But then we have this 3. So 3 would be our potential, and we eliminate our nodes actually. So what can we do is to Yeah, so how to solve it? So we would have like a set of children's. So we start with f0 and we go to 1 and 2. Then from 1 and 2 we go, we go to 2, and for 2 we cannot go anywhere. Okay, then again we go to, and we have potential winner. Or even I think we don't need it. So then we have, like, we go to 1 is already in children, so we are not checking it. Then we have 3. So by 3 we go to 0 and add this 0. So from 0 we again see 1 and 2, so we are not going here. Then we have 4, so from 4 we go to here, and we actually have this set. So after we have all this set, we go by n, and if n, so first of all, if this set is greater, is not equal to -1, like we have only one winner, then we just return -1. Otherwise, we go through n, from 0 to n, and check this set. So how can we do this? We can do this recursively, I think. So let's try to do it recursively. So first of all, we need map of integer, then we need set visited, then we need to iterate over our map and key set, and call recursive function and add key our map and visited. Then we check if n minus visited size is equal to 1, else, if it's not equal to 1, we return -1. Otherwise, we are going here, return -1. Otherwise, we are going by every node, and we are checking if visited contains I. So if it's not contains, we return this I. Yeah, so now it's left to implement this recursive function. So by recursive function, we have our key, then we have our map, let me get. Okay, I add charger, so let's continue. We have this visited, and here if map Yeah, but when we iterate, and we actually don't want to have yeah, so we actually, here we don't have only one integer, but we have a list of integers. And here also list integer. No, here it will be key, but we want to do like get by key. And yeah, so all these keys all these keys we should we should, I think, iterate over all these keys, and maybe even like this. So we have our key, then we have inter connection, something like this. Connection. And here we have only connection. And we check if visited contains connection, we return. Otherwise, we add in this connection, and we add in this connection, then just iterate and over map get connection. Next, and here we call a recursion function with next and map and visit. Yeah, something like this. Okay. So let's try to dry run this code. So for example, let's take such example when we have n equals to 3 and edges have 0, 1, 1, 2. Yeah, we also need to populate actually this map. So by populating this map, we need to iterate over edges, and here we need to put edge 0, map get or default. Okay, or default, it will be new realist. Okay. Here map get and add edge 1. And yeah, so here we populated our map, then we have our visited. We are going through our connection. So for example, here we have 0, we have 1. So we put this recursion with 1. we add in this one to visit it. And yeah, and we are getting from map from 1 we get 2, and call recursion function with 2. So 2 is not contains, we add 2 here, and from 2 we get null, and if map get con equal to null, then we just return. Okay. Yes. Then we have 1. So from so from 1, so map get 1, we get connection 2, 2 contains, so we just return. Then we have n that equals to 3, visited size is equal to 1, to 2, so it would be 1, so we are going here, and then we check like 0 exists. No, it's not exist, so we just return 0. So let's run. Okay. Run. Okay, let's submit. All right, so we're done, but we have more faster solution. So let's check faster solution. Okay, yeah, nice. So I think that's it. Thank you very much, and see you next time.